So we're going to talk about the standard model of the atom. This is what we've realized, all the research that we've done, and what scientists have discovered up to now. So what they say is the standard model of the atom. We know that we have protons, neutrons, and electrons, but they've actually found even more particles even smaller than that. The electrons float in a cloud 1,000 times bigger than the nucleus. The electrons have the most volume of the atom, but they are so light and so small that they actually don't really even weigh very much compared to our other particles. What we found is that we discovered that protons and neutrons are actually made up of particles called quarks, even smaller particles. They discovered these by using particle accelerators to smash subatomic particles. These particle accelerators, beginning with the machine at the Stanford Linear Accelerator Center, accelerated charged proton and electron particles to tremendous speeds and then forced them to collide with or smash into target material. The collisions caused the protons and neutrons to break apart, and quarks were identified in the particle tracks as some of the broken bits that scattered following the collisions. The quark, which was proposed independently by physicists Murray Gell-Mann and George Zweig in 1964, was confirmed when investigators at the Stanford Lab and Acceleration Center found the first quark in 1968. It took until 1995 to identify the last type of quark, when the top quark was spotted in collision results at Fermilab. So what we notice is that we have even smaller particles than what we thought. You might not have even heard about quarks before, because a lot of times it's so new that teachers and scientists don't really even understand them completely yet. If you've ever seen the video or read the comic books Flash, like Marvel Flash, the particle accelerator in there is what gave Flash his speed. That's similar to the particle accelerators that they use to find these. Not quite as big, but the same idea of how they use the particle accelerators in those videos. You're probably going to want to watch this video to get a background on quarks. It's linked into your main page if you want to go there and watch the video. So a quark is an elementary particle, which means it can't be broken down. Elementary particle or fundamental particles, whatever you want to call them. We say yet behind that because we used to say that atoms were these elementary particle as well. So we don't know for sure. Maybe there's something that makes up quarks as well. Our quarks combine to form composite particles called hadrons. The most stable hadrons are protons and neutrons. Quarks do not exist in isolation, so nearly everything we know about them is just deduced from the examination of other particles and the particle reactions. Most of that work is done in high-energy physics laboratories where particle accelerators are used on the experiments. But the main things to remember, we have quarks. We also have a couple other particles called leptons and bosons. Leptons include electron, muon, tau, and neutrinos. The electron is a type of lepton, so unlike the proton and neutron, which are made up of quarks, the electron is a lepton, a completely different particle. Then we have bosons, which are force particles. We have gluon, photon, strong force, graviton, Higgs, and weak force. The gluon is kind of the force that holds our quarks together, so that's a good way to remember that. Gluon's like the glue that sticks them together. These particles were organized by spin, charge, mass, and their lifetime. And you can see the different particles here. More specifically speaking about quarks, we have an up and down, charm and strange, top and bottom. And again, they got their name from the book Finnegan's Wake by James Joyce, just from the line 3 quarks for muster mark. Not really even sure how that even takes play in it, but they thought it was a cool name. So Murray Gell-Mann found that book, the name quark in that book, and then he received the Nobel Prize in 1969 for his work in classifying these elementary particles. So remember, 2 up quarks and 1 down quark is what makes a proton. 2 down quarks and 1 up quark make a neutron. Electrons are not made up of quarks at all. Remember, electrons are a type of lepton. So if we go into our hadrons, this is what the quarks are made up of. Hadrons. Hadrons are particles composed of quarks, other way around. What happens here, we have mesons. They're made up of 2 quarks, a quark and an antiquark. And all an antiquark is just the exact same or corresponding quark, but spinning the opposite direction. Mesons hold protons and neutrons together to hold them into the nucleus. That's what the goal of mesons is. When you do the What is Matter worksheet, you will notice these different things and understand them a little better. We have baryons. They're made up of 3 quarks. Protons and neutrons are a type of baryon. So you can see down here we have a meson. They have anti-green and green, so it's just the green and anti-green, the opposite direction. A baryon has 3. They're all quarks or all antiquarks. And then we have an antibaryon where they're all antiquarks. Again, protons and neutrons are made of quarks. They are both baryons. Electrons are the type of electron. Those are the main things to remember. Gluons are the force that holds the quarks together to make the mesons and baryons.